And to finish off the packet, so let's keep going from number 16. So number 16, you have the two vectors A and B, and you want to know again the sum of those two vectors, so you just add those components, and that's your answer. Then for number 17, they are giving you the components of vector E, and they want to know the angle. So what you can do again, and they say again from the x-axis to the vector. So what I did, I used the usual theta here, the little theta, so doing the rise over run, and I calculate this theta as 34 degrees, so I do the y over x. So 34 degrees is that one, but then I remember that they said that they wanted to know from the x-axis, so this needs to be added with the 180 degrees coming from this flat angle there. So 214 is going to be your answer, which is B. Then for number 18, they want to know magnitude of vector C. Vector C, okay, where C is the same vector as before, the one that you just calculated. No, is vector A and B are shown. So you have the picture for those two vectors. Let me see what it is. 17. Okay, so those are the two vectors A and B, and C is the sum of those two. So they want to know which one is the sum of those two vectors. So you have magnitude, you have angle, therefore you have the cosine as the y component, x component, the sine as the y component. This one is your cosine for the ax, and this is your sine for the ay. So at that point, you just write those components right there, you add them up, and that's your magnitude. So C is your answer. Then for 18, they want to know the magnitude. So, oh, that's 18. For 19, actually, you do have some trouble there probably because that's something we didn't cover in the last year course. So just for brief information, I wrote some notes for you that you're welcome to read. Actually, I would appreciate it if you do, because they want to know according to the vector that they are giving you. And again, those are the vectors. So this is number. So those are the vectors from number 19 to 21. You refer to this picture. And if you have three vectors like that, they want to know, first of all, what happens when you have the cross product. So, so far you have seen the dot product, right? When you have A dot B, and that means A magnitude of A times magnitude of B times the cosine between the two vectors A and B. This one instead, we briefly touched it, and I told you not to worry because we didn't touch it last year. But when you see cross, this means actually that your product is going to be a vector. So what I wrote here is that when you have the operator indicated with the X, this is a cross product, okay? And it's not the same as the dot product, which is the one that you used already to know. Now, two main differences are the following. So like I said, A dot B, it is a scalar. And the calculation that you do are such that if you have those two components, you multiply the x components and the y components and the z components, and you add them up. That will give you the value of the scalar. Whereas if instead you have magnitudes and the angle, you multiply those stuff together and you have exactly the same number that you have in this situation. So how do you know which to use? Well, it depends, obviously, if you do have all of the components or if you have the angle, right? But like we saw before, you could have the components with which to calculate those two magnitudes, and you're asked to calculate the cosine instead, or to calculate the angle. In that case, you will put this value equal to this value because both of them are equal to the A dot B, right? And you will solve for the cosine or whatever else you asked to evaluate. When did we use this kind of stuff? Well, for sure, when we talked about work, because you do have force dot displacement. It's extremely important to remember or to learn the difference between those two values. So also remember that if you're applying a force, for example, in this case, you're pulling a block and you're making the block slide across the floor, right? By pulling up, you're decreasing also the friction, right? So the push of the block on the surface. So you have also to consider not the whole, for example, 100 Newton that you will apply, but the only component that contributes to the motion of the body is actually the cosine, right? So the F cosine theta times the D is going to give you your work. So basically what you're doing is you're doing the dot product between force and displacement. Now, what happens instead when you do the cross? Well, when you do the cross product instead, you're basically having one more vector which has a direction perpendicular to the plane on which A and B lie. So you're going to see this as soon as we start talking about torques, or definitely when you talk about magnetic fields and stuff like that. But how to calculate it, you got to know it right now. So when you do the A cross B, this is now a vector C, it's not just a scalar, and it's the same as doing the product between A, B, and the sine of theta. So for number 19, they are asking where does the vector perpendicular to those two lie? So we lie on a plane perpendicular to both vectors. So you get to say, so since the picture of those vectors is on the page, the perpendicular direction is either going into the page or coming out from the page. Because on your page you have the X and Y axis, so you're looking for the Z direction, which is perpendicular to X and Y. Now your question would be, according to those pictures, if you're doing A cross B, right, which one is the direction? So first of all, you're doing A cross B. So I would like you to put your hands like a knife, so straight on your palm, okay, and align your palm, your fingers in the direction of A. The order is important. So they are saying A cross B. So you point your fingers on A, along A, and you curl your finger toward B. So that's your picture, right? So you align your finger across A and you will curl them. What did I say? A. So you align those fingers on A and you curl them toward B. Now, when you curl them, right, you can only curl them if you actually go with the thumb pointing into the paper. Otherwise, you can now move your hands curling toward the back of your hand, right? So your thumb is going to be pointing downward. So this means that you got to choose into the plane. At that point also you got to evaluate. So you know that the choice are going to be anything that says into. So either B or D according to your paper there, right? So either B into the plane or D into the plane. But which one is the right amount? Is 20 or 13? Now, if you do evaluate it and you do A, B, sine, you will see that you have a 13 in place. So 4 times 5, sine 40 is 13. So 13 is into your page, into the page. So that's your answer. Okay. And then 20, now you have C cross B. So you still have to do 9 times 5 times the sine of 60, which is 39. Again, it's into the paper or out of the paper. So you have C cross B. So you point your fingers along C and you curl toward B. Where is your thumb pointing? So in this case, you point with the thumb up, right, along C, and you can curl toward B. So thumb up is fine, okay? So it's out of the page. Okay, so out of the page is the right answer, and your number, what was it? It's 39. Okay, so 39 out of the page, so that would be your answer. And so E. And then for 21, how do you do the A dot B? Well, you know, it's 4 times 5, right? Those are the two magnitudes, cosine 40, right? So AB is this, right? AB. So 4 times 5 times the cosine of the angle between them. So that's easy. Okay. And for 22, okay, for 22, you can actually leave it behind because you don't know how to do this. And we will do this in class, okay? But Father Kenneth will be very, very proud of you if you can solve this. So that's it. Study hard and see you soon.